Hello everyone, my name is Krishna Bodhe from Pudar International School, Varda. I am studying in 8th standard. Today I have made a project for the competition We the Thinkers by Bajaj Science Center, Varda. My project name is Nitrogen and Methane from Bagasse flue gases. So what is a bagasse? Bagasse is one of the fuel which is excreted from the sugar industry after the whole of the cane is crushed, and it is just like an sawdust which is burnt in the boiler to form steam. So my project is for sugar industry, and in India, sugar industry is the second largest agriculture-based industry and contributes significantly in socio-economic development. Also, it is the largest. India is the largest producer of sugar after Brazil. India, besides sugar, also produces 1300 megawatt of electricity for export, and currently the industry is also engaged in ethanol production from the fermentation of molasses and sugarcane juice. So in this industry, no waste product is put out other than the flue gases after the combustion of the gas. Means when the gas is burnt, the gases liberated are known as flue gases, and except them, no other gas is put out. And this is the only waste that we are getting, that is flue gas. Considering this way, I have selected this industry. Also now sometimes uh, the sugar industry is also suffering from financial crunch. So considering this all crisis, I have selected the sugar industry for my project, that is CO2 to methane and collection of nitrogen from the bagasse flue gases. In India, sugar plant having capacity of 1200 to 10,000 metric ton. Means a small plant may have a capacity of 1200 metric ton, and the largest plant may have the capacity till 10,000 metric ton cane crushing per day. Means 10,000 metric ton cane crushing per day will be the largest plant, and 1200 metric ton cane crushing per day will be the smallest plant. For this project, I have selected a plant for 2,500 metric ton cane crushing per day. So that plant which will crush 2,500 metric ton cane per day will crush 3 lakh metric ton of cane in a season, which is of 4 to 5 months, and the 3 lakh metric ton of the cane will give me 30% of the cane will be bagasse. Means we are getting 90,000 metric ton of bagasse. So here is the all the explanation for my project. That is, first bagasse is burnt in the furnace. The gases are put out in the tank. Here the gases are nitrogen, water, carbon monoxide and carbon dioxide are the flue gases which are liberated from the bagasse. From 1 metric ton of bagasse, we are getting 1.7 metric ton of carbon dioxide, because the oxygen is reacting with the carbon in the bagasse. So the volume of the carbon dioxide will be more than the volume of the bagasse. Also, the nitrogen is the most dominant gas after the combustion, which is 74% present. And from 1 metric ton of gas, we will get 5.1 metric ton of nitrogen, and then these gases are passed for the further process. So here the blue line represent the carbon capture filter, which only trap the carbon dioxide molecule and let other molecules go out. So here we are trapping the carbon dioxide and putting it into this tank, and other molecules we are letting it go, other gases we are letting it go. And then because there is a lot of nitrogen, this can be collected for our next profits. So this is a nitrogen membrane, which is a device which nitrogen membrane is a device which only allows nitrogen to pass through it and resist other gases to an another way. So this is an animation for it. Here only nitrogen gas is passed and other gases are excreted out. So here the nitrogen membrane will act for collection of nitrogen, and the other gases would be liberated. Now the CO2 that we have collected would be compressed in one tank and then passed for the reaction. Now here the real game is, our CO2 will react with 4 hydrogen molecules to form CH4 plus 2 H2O. Means it will do 1 methane molecule and 2 water molecule in presence of ruthenium as a catalyst. So CO2 is a very unreactive gas, but still in presence of ruthenium as a catalyst at 400 degrees Celsius, it reacts with hydrogen to form methane and two water molecules. So here is the hydrogen source, and here is the methane and water excretion. So this is the main law of my project, and then this is the main reaction. This is ruthenium, and as I told you that the reaction in 400 degrees Celsius with only ruthenium as a catalyst, but with cerium oxide nanoparticles, if we add with ruthenium in presence of electric field, the reaction will take place only at 100 degrees Celsius, and we will gain the same reaction at an efficient rate. So here is an animation. First gas is burned, then its flue gases are collected, and then it are passed. CO2 is scrapped from the nitrogen membrane. The other gases are passed. So other gases are liberated out, and the nitrogen gas is separated and then further processed. So then we are compressing the CO2, then passing it to the reaction chamber where the reaction is done, and then hydrogen gas we are here from externally supplying, and then we are getting the methane as an output. So amount of CO2 got, this is a theoretical calculation. So from 1 metric ton of the gas, 1.7 metric ton of CO2 we are getting. So from 90,000 metric ton of the gas, we will get 1,53,000 of metric ton of CO2, which is a very huge amount, and if liberated in atmosphere directly can cause a lot of global warming. So our basic reaction for the production of methane is CO2 plus 4H2O in presence of ruthenium and CiO2 nanoparticles in electric field will give CH4 plus 2H2O at an efficient rate. For this basic reaction, by mole calculation, 44 gram of carbon dioxide, we need 8 grams of hydrogen to give 16 grams of methane and 36 grams of water. So requirement of hydrogen, which is a very crucial thing for our project. So here I am taking the maximum expense and minimum profit, and the most expensive type of hydrogen, that is green hydrogen. So the total hydrogen we are needing by mole calculation is 27810 metric ton of hydrogen for 1,53,000 metric ton of CO2 to be converted into methane. So 1 metric ton of hydrogen, here we are taking the cost as 4 lakh rupees, but if we buy a blue hydrogen at the minimum expense, it just costs 98,000 rupees. And so the total cost for hydrogen is 1,112 crores. And in this project, we are purchasing hydrogen from market, which is more expensive. But if we purchase the hydrogen, if we are able to make the hydrogen in the factory, it would be a bit less expensive. And there are several methods for the preparation of hydrogen, like electrolysis, photoelectrolytic using nanosilicon, but needs research and viability for the hydrogen plants. So the amount of methane that we are getting, so for 44 gram of CO2 we will get 16 gram of methane. So from 1,53,000 metric ton of CO2 we will get 55636 metric ton of carbon methane. So cost of 1 metric ton of methane is 45,000 rupees. Considering this, we are getting rupees 250 crore. Now one would think that this plant is in very loss, but no, this plant will gain the profit further. So the nitrogen is going to give the plant profit, because nitrogen is the most abundant gas released after the combustion, and therefore trapping it and getting it is a very good thing, because it can give a huge profit and dilute the cost of hydrogen. But whereas if we in the methane only use a blue hydrogen, then it would be very cheap and would dilute the cost of methane as well as hydrogen, and we would get nitrogen for a profit. So the total cost of nitrogen I'm taking for 1 metric ton is 30,000 rupees. So all over I will get 1377 crores of hydrogen gas when sold. So our net profit is 515 crore, which is the cost of nitrogen plus cost of methane minus hydrogen price. So the net profit we are getting is 15 crore, 515 crores. So to produce methane from carbon dioxide is a non-profitable when green hydrogen is used, and expensive, but by research and development the price can be reduced, and using blue hydrogen will our cost be diluted for methane as well as for hydrogen, and we will get the profit for nitrogen. But this project is very important, because if we do not now convert the CO2 into methane, then for the further we would suffer a lot with global warming. And here in this project, methane do not give any economic profit, but the environment, we have to do it for the environment, because by putting a side plant such as here I have put the nitrogen plant, we can get the profit. By the loss, we are getting a huge profit, that is 515 crores. So change in carbon dioxide on the globe is the more than the loss. Means we are not any getting a loss, but we are in the profit. But still, by putting this nitrogen plant, we can get a huge profit, but we can't save the globe. So for saving the globe, we need to put the carbon dioxide methane plant with nitrogen as a side plant. So that's what all for my project. Thank you. If you like the project, then do like it, and don't forget to comment that how was it, and if any query on the project. Thank you.